Hi everyone, welcome to section 11.4. We're going to talk about conditional probability in this section. And that's what's the probability of something happening or of this given this. Okay, so what I've done to kind of introduce this is I've put on the board, same as what's in your book. This is a list of students at different colleges. These are two-year colleges or two-year programs, four-year university students and graduate students. These are males and they're females, and these numbers actually represent the thousands. So these are students in different types of schools, and this is actually from 2005. Okay, so let's say you pick a student at random. What is the probability? What is the probability that the student is female given that they're in graduate school? All right. So the condition is that they're in graduate school. Now, what that does is that limits all the possible outcomes on the bottom. So what you're going to do then is you're going to find the females out of just the graduate students. So our sample space, instead of it being all the college universities, all of them everywhere, it's going to be the graduate schools. So you're going to add these two numbers together, 1349 and 1954, and that's, what is that? It's a big number, 3303, I think. So 3303 is the total sample space that we're drawing from. And now what's the probability that it's a female? That would be 1954. And so the probability is 1954 out of the 3303 total graduate students. That would be the probability that it's a female given that it's a graduate student. All right, and so you find that and it ends up about 0.59%, 0.59%. Okay, that's what that means. All right, what is in this same chart? What is just the probability that the student is female? The probability that the student is female. Okay, so now to find that, it's the total number of females divided by the total number of students. So that's bigger. So you have to add all of these three numbers to get your top number, the total number of females, and then which is going to be 9933. And that's going to be divided by all of the college students in total. So you need to add all six of these numbers up to get the total number of students, which is 17,472. And that's what you do. You divide the total number of females divided by all of the students in all of the colleges, and you get about 0.57, or about 57% or female in 2005. Okay, that's to see the difference, straight probability and then the conditional probability that limited that sample space. So I'm going to give you one to figure from the same chart, so we don't have to write anything new. I would like you to find what's the probability that your student is from a four-year school given that your student is a male. Okay? What's the probability that it's a four-year student given that your student is a male? All right, do you know how to do that? Okay, try it. See if you get the right answer. Okay, you should have gotten about 0.57, something like that, 0.57355. So about 57.4%, 57.355% is that your student is a four-year given that the student is a male. How did you do with that? If you got something different, step back and look. at the combination and what you did and see if you can figure that out. Okay, let's move on to the next one. Okay, we have a new chart now on the board. This is a chart that represents recycled waste in the year 2007 in the American people recycled. So on this left column is the amount that is recycled. What is this? This is in millions of tons. Millions of tons. So 45.2 million tons of paper were recycled. This is the waste that was not recycled. 37.8 million tons of paper were not recycled. So that gives you an idea of how to read this chart, and this is for the year 2007. So based on this information, what is, what am I looking for? What is the probability that, where's the question? What is the probability that a sample of recycled waste is paper? So I want to know, what is the probability that a sample of recycled waste happens to be paper? Okay. So basically, what I'm looking for, what is the probability that it's paper given that it's recycled? Okay. What percentage of recycled waste is paper? What's the probability that it's paper given that it's recycled? So that means I'm dealing with this column right here. So my sample space is just the recycled part, and I am going to add up all of these numbers to get the bottom. The paper is 45.2. So it's 45.2 out of the total of these, which happens to be, I don't know what it is. It's a big number. In any case, when you divide that, you get about 57%. Okay? That's how you would do that kind of question with this. All right. Let me ask you another one where the answer is not in the book and see if you can figure it out. What is the probability that a sample of recycled waste is plastic? A sample of recycled waste is plastic. Okay, so I'm not going to help you. You figure that out. A sample of recycled waste is plastic. Figure that out. Come back and check. Okay, did you get about 2.64%? So that was 0.026448. Okay? All right, let's do another one. What is the probability that a sample of recycled waste is glass? Probability that a sample of recycled waste is glass. Figure that out. Did you get 4.03% or 0.040302? Okay, if you did, huzzah, you are totally getting this. Yes, that's conditional probability. And so it really it limits or restricts the sample space. Not too bad. That's good. So the here's the formula. Let me go ahead and erase this and show you the formula that the book has, because this can be helpful, and sometimes you're going to need this because it can get more complicated and confusing. At least to me it does. So the probability of B given A, all right, which is what we're doing, is the probability of B and A, or A and B, like for instance in that last one we just did, when we did the first one, it was both recycled and paper. That was my top number. And then divided by the probability of A, which was all the recycled stuff. Okay, so here's what it looks like in a nice little formula. And then when you did the glass, the probability that it was recycled and glass, that was your top number. The bottom number was just all the recycled. That's what this means, okay? All right, let's look at some more using this formula and see how it can help us. Let's look at bills, people who pay bills. So people, some pay bills online, some pay them by mail. And I think each year more and more people are going online than previous years. But we're looking at men and women. What are the differences? This is 12, 24, and this is 8 and 6. Okay, so here is our data for how people pay their bills. And this is a utility company. They asked 50 of their customers. So there's 50 total people here. They asked 50 of their customers whether they pay their bills online or by mail, and this is what they got. So my question to you is, what is the probability that a customer pays the bill online given that the customer is male? Okay, pays the bill online given that the customer is male. Out of this. Okay, so looking at this type of situation right here, the top number is male and online, which would be 12, right? And then the given that, oh, wait a minute, it's not 12. Sorry, it's not 12 because this is a probability. Yikes, sorry about that. This is, I told you it gets confusing. All right, so the probability of A and B is male and online, right? That's what we're looking for. That's 12 out of 50. So this is 12 out of 50. That's this top number divided by, that's the probability that this person is male. And the probability that this person is male is 20 out of the 50. That's how you do it. Okay, it's not just 12 out of 20. Okay, the probability that a randomly, that a customer, given that the customer is male, what's the probability he plays online? So 12 out of 50 divided by 20 out of 50, and it gives you about 3 out of 5. Okay? Actually, that is the same as 12 out of 20, isn't it? 3 out of 5. It's just the same as 12 out of 20. All right? Or 3 out of 5, 60%, 0.6. Okay. Okay, here's another chart. This is a survey that was done between men and women on when they shower, if they apply their shampoo directly to their head or indirectly by pouring it into their hand first. Who knew that was important? But somebody did a survey for that. Here's what they found. Here's the numbers that they got. By the way, it looks like most people put their shampoo on their hand first. But anyway, what's the probability that how do I want to word this? I want to make sure I do it right. What's the probability that a respondent applies shampoo directly to the head given that the respondent is female? Okay, so what's the probability that somebody who responded applies directly to the head given that the respondent is female? Figure that out and see if you get the right answer for this one. Okay, did you get 0.2? Did you get 0.2? Did you use this? Okay, that's the right answer for that one is 0.2. Okay, let's move on. I want to show you how to use a tree diagram. Okay, here is a tree diagram. This is a school system came up with this. They compiled a list. What they had done is they took a survey to people who had been juniors in high school 10 years earlier. So they went 10 years after they had been juniors and they surveyed these students and followed them. And they found that 85% of those juniors graduated from the high school. 15% did not graduate. So we have that kind of. And then they asked them so many years later if they were happy or not happy in their work. So of those, so here when they asked those who were graduated, 90% of those who had graduated said yes, they were happy in their work. 10% said no, I'm not happy in my job, I don't like it at all. Of those who didn't graduate, 60% of those were happy in their work and 40% were not happy. So notice this is a tree diagram. This branch represents those who graduated. This branch represents those who did not graduate. This represents those who are happy, not happy, off of the graduates. Do you see how it just kind of filters off from there? This is what each second branch represents, this second branch represents a conditional probability, doesn't it? So here is those who are not happy given that they graduated, right? That's kind of the idea. This is the probability that they were happy given that they graduated, that type of thing, all right? That's how to read this. Does that kind of make sense? What is the probability that a person from the junior class 10 years ago graduated from high school and is happy with his or her job? Oh, okay. So we want to know they graduated from high school and they are happy with his or her job. It's not 90% of everybody, is it? That's not going to be the right answer. So what we do then to find out what's the probability that one of the juniors out of all of them happens to be happy given that they graduated. So what you do then to find that probability is you take the probability that they graduated times the probability that they are happy having graduated. 0.85 times 0.90. And that gives you the average of 0.765. 0.765. Okay? That is that they are graduated and happy, right? Okay, probability that person graduated and is happy with his or her job. There we go. All right. What's the probability? Let's see how well you understood how we did that. What's the probability that a student from the junior class 10 years ago in problem 4, did not graduate and is happy? Okay, what's the probability that a student from this time did not graduate and is happy? And see what you got. Did you get that that probability is 9% or 0.09? Okay? 0.15 times 0.6. All right, that's how you can use a tree diagram to help you with some of these things. It can be helpful at times. So that's a tree diagram. That's how they work. And that's conditional probability, and it takes practice to get better at it, but that's it for now. That's section 11.4. So I will see you guys next time. In the meantime, have fun with this as best you can, and I'll see you next when we work on 11.5 coming up next. Bye for now.